I think my screen is visible to all. This is the first question of week 5. The question is that find the value of R1 when frequency is 50 kilohertz and capacitance is 0.1. Frequency is 50 kilohertz and the capacitor is 0.1. I think it is a it is a 0.1 microfarad, I think so. Yeah, it is a 0.1 microfarad. Yeah, 0.1 microfarad. Okay, and V out upon V in is minus 50. Okay, so we can simply use what? Either I use the KCL, so the current that is going from this way, the current that is going outside to the feedback. Okay, the biasing is, if we are talking about the feedback, so feedback is negative. If feedback is negative, that means apply the virtual ground concept. The V positive is equal to V negative, and that is 0. So this voltage is 0. Now can I apply the KCL here? So Vi minus 0 upon the series combination of R1 plus 1 by Cs is equal to 0 minus V out upon Rf. Okay, so minus V out by V in is equal to Rf. If I take the denominator side as LCM Cs, so Rf Cs upon 1 plus R1 Cs. Okay, now V out upon V in is given, that is a 50. Minus 50 and minus minus become plus, is equal to Rf Cs upon 1 plus R1 Cs and mode of this one. Okay, so 50 is equal to, if I replace S is equal to j omega, so j omega Rf C upon 1 plus j omega R1C and mode of this one. Okay, so the numerator mode is the omega RFC and the denominator mode is 1 plus omega R1C whole square, and that value is equal to the 50. Okay, now put the value of omega, put the value of RF, C omega value is already given in the question. Okay,
Sir, we will put the values.
yeah, so you can calculate the value of R. Question number 2 in the same circuit as Q1, if the voltage gain is 100 and R1 is similar to the previous calculated value, then the value of R. Now what we do? We change the V out by V in. That is 100 now. Okay, and that is equal to
Sir, minus 100 है ना?
minus 100 and minus minus cancel out.
Okay.
Minus 3 out. So J omega RFC upon 1 plus J omega R1C. Okay, and mod of this one. Now, if I take the magnitude, so omega RFC as the numerator, and then the denominator, it is a 1 plus omega R1C whole square. Okay, now R1 value that we calculated from here, we can put the value of R1 here and calculate now RF.
Yes, sir.
The magnitude of the voltage gain at DC is equal to 0. So first of all, what we do? Calculate the transfer function of this one. Now, if I say this is the R1, this is the R2. So again, apply the virtual ground concept. Okay, so this voltage becomes 0. Why? Because this voltage is 0. So V1 Vi minus 0 upon R is equal to 0 minus V naught upon root of, or not root, R2 parallel combination with 1 by 6. So Vi by R1 is equal to minus V naught upon, if I take the parallel combination, so R2 multiplied by 1 by CS upon R2 plus 1 by CS. Okay, so Vi upon R1 is equal to minus V naught upon R2 upon 1 plus R2 CS. Okay, so minus V naught upon Vi is equal to R2 by R1 into 1 upon 1 plus R2 CS. Okay, now we have to calculate the magnitude. So magnitude is V naught by Vi minus and mod of this one. So that is equal to the V naught upon Vi, that is R2 by R1 plus 1 upon 1 plus R2 CS. Mod of this R2 CS. Or I can take directly the root of 1 plus omega, not J, omega R2C whole square. Okay, now given that omega is 0, so what is the value? V naught upon Vi mod is equal to, this component is 1, so remaining is R2 by R1, that is 60 by 3 is equal to 20. Question number 4. Now it is saying that we calculate the frequency at which the magnitude is 1 upon root 3 times of the DC value. So initially the DC value is what? 20. Now 20 root 3 is equal to R2 by R1 1 over root of 1 plus omega r2c whole square. So this value is 20. So 20 and 20 will be cancelled out. So root 3 is equal to 1 over 1 plus omega r2c whole square. Okay, take a square. So 3 is equal to 1 plus omega r2c whole square. Omega r2c is equal to root of 2 by 3. There is some mistake in the question. It is a 1 upon root 3 times of the DC value. Then your answer will be correct. Okay, so but in question it is a given at root 3 times. It is a basically 1 upon root 3 times. So if you calculated 1 upon root 3 times, so the answer should be correct. Okay. Because your magnitude is maximum, like if you are talking about it is a filter. So at DC value, the magnitude is maximum. So when we increase the frequency, the magnitude is decreases. Okay, the magnitude is decreases, but what we consider that it is a 20 root 3. That means the value will is higher. The value is higher. That is not possible for the filter. Okay, that is not possible for the case of filter. So it is a 20 by root 3. If you solve by this, that is the correct value. Okay, so because if you see the here, the problem is that if I take 1 at this side, so it is minus 2 by 3. Okay, and if I take the omega r1c is the minus root 2 by 3, that is the root 2 by 3 iota. Okay, complex quantity. That is not possible. Okay, so this is the problem. So you solve this by 20 upon root 3. Wait a minute. Hello, am I audible?
Yes, sir.
Yes, sir.
So it is a 1 upon root 3 times. So we solve with the 1 upon root 3 times. So it is a DC value is 20. Now the magnitude is 20 root 3. 20 upon root 3. Okay, 20 upon root. Okay, so that is the R2 by R1. Now the value of R2 by R1 is 20. Okay, because if you go in the question part, R2 is 60 and R1 is 3. 60 divided by 3 is 20. So can I cancel out these and this? So 1 upon root 3 is equal to 1 upon root 1 plus omega R2C square. Okay, take a square, and so 3 is equal to 1 plus omega R2C square. So root 2 is equal to omega R2C. So omega is root 2 upon R2C. Okay, you can calculate the omega. Now after calculating the omega, you can calculate the frequency. Frequency is root 2 times 2 pi R2C. Okay, so by putting the value of R2 and C, you can calculate the frequency. Any doubt? Yes, any doubt?
No, sir.
Okay. Now we go to the question number 5. Now calculate the cutoff frequency. Okay, again apply the virtual ground concept. Again apply the virtual ground concept. This voltage becomes 0 volt. So Vi minus 0 upon R1 plus 1 by Cs. This is R1. That is equal to 0 minus V naught upon R. Okay, so basically minus V naught upon V1 is equal to R2 upon R1 plus 1 by Cs, that is R2 Cs upon R1 Cs plus 1. The magnitude is omega C R2 upon 1 plus omega C R1 plus. Okay, now how we calculate the cutoff frequency? How can we calculate the cutoff frequency? Any idea how can we calculate the cutoff frequency?
Three dB.
Hmm?
3 dB.
3 dB, yeah. Okay, so basically we can say when we draw the curve, or we can discuss in the previous class, if this is my low pass filter response. Okay, so the where the magnitude value will be 1 upon root 2 times of the maximum. Okay, we can calculate this is the my cutoff frequency. So the magnitude value is 1 upon root 2 is equal to omega c r2 upon 1 plus omega c r1 square. Take a square. So 2 of omega c r2 whole square, that is equal to 1 plus omega c r1 whole square. Okay. Now you can calculate the value of omega. Any doubt? Yes, any doubt? Shall we move further?
Yes, sir.
Okay. Now the next question is, hmm, now what we do in the question number 6, we are already V naught by Vi, that is equal to omega c r2 upon 1 plus omega c r1. Okay, now omega is what? That omega. Now here what I do, I just note down is omega c cutoff frequency. Okay, I replace this one as a omega c cutoff. So now in this case, omega is what? Twice of omega c. Okay, so now they are asking what is the gain. Okay, so put the value of omega is equal to omega c and calculate the value. That is the gain. Yes. Can you solve it? Another question number 7. For a given circuit, the real force of the quality factor. Now, are you trying to solve it by on? Are you trying to solve it by on? Can you try by on? Just how we solve this question? Students, am I audible? So how we solve this question? If you go through with the weak content, so you can check that how can we solve this question. Any idea? Can we apply the same concept, virtual ground? This point voltage is what? Give you the hint. This point voltage V plus. This point voltage V minus. Okay. Now what is the V minus first of all? Now let's take it that there is one resistance of 1 ohm and there is a resistance of 1 ohm. Okay. So this due to this output voltage, the current is flowing in this direction. So what is the voltage drop at this point? This is not a zero. Okay, just remember that this is not a zero. Now can you solve it? Can you try to solve it? Let's solve it. No one is doing. Why? Okay, so this is for you. You can solve this question now. For the above circuit in question number 8, the corner frequency. Okay, so I just tell you that you have to solve this particular question and calculate the V naught upon Vi, that is the in the form of 1 plus S square upon omega P square plus S upon omega P QP. Okay, so first of all you have to calculate the omega P by equating the equation is 1 plus A S square plus Bs. Okay, so omega P is 1 upon A and root of this one. Now after calculating the omega P, you have to calculate the QP. So QP is nothing but omega P QP is nothing but equal to the B, the Y upon B, and QP is equal to, when I take omega P, so it becomes A root A by B, like this. Okay, so you can calculate both terms, omega P and QP. Any other doubts? Try to solve this question. I'll leave this question for you. Any other doubts? If you have any doubt, you can ask. I think no doubts. Am I audible or not? Okay. Student, I will share either till Monday one mock test with you also. Okay, that is a similar pattern is similar like it is a pen paper. I just give you a sheet, upload in the on the portal, so you can solve this one. And if you have any doubt, you can ask me after solving that one. Okay, so that is for week 1 to week 4. Anything else? Yes, if you have any doubt, you can ask. Okay, so shall we close this meeting?